Do you all have a pencil? Just go and get it. A pencil. Okay. All right. Fine. We'll start with the experiments first, okay? Then we'll move on to the discussion. Yeah. So, what you need is, what are the materials? You put it on the table, okay? We need to identify which are metals and which are non-metals. So these are safety pins, iron nails, chalk, aluminium foil, okay, paper, and just 1 second. Collect all the materials. And cardboard. Okay, cardboard, paper, chalk, safety pins, iron nails, aluminium foil. So look at all. We cannot see your materials. Can you show us one by one?
These are my materials.
Okay, what do you have, Janvi? Can you tell us?
Pencil.
Okay, pencil is not used for this experiment. You can keep it aside. Yeah.
Foil, copper wire, nails.
Okay.
Ma'am, I have all the materials except cardboard and battery holder.
Okay, fine. For this experiment, cardboard is only required. Okay. Then, Nishraya. You're on mute, Nishraya.
I have safety pins and iron nail, chalk, and the paper.
Okay. Now, all of you will tell me one by one which is shiny and which is not shiny, which has a shine and which does not have a shine. Okay. Show it and tell us, like paper. Okay. Does it have a shine? So what it will be called a non-metal, okay, because it's not a metal. It does not have a shine, so it's a non-metal. What about this cardboard? Does it have a shine? No. So what is it?
Non-metal.
Non-metal. Now you all show me one by one and tell me what are metals and what are non-metals. And we can start with Nishraya.
Safety pin is a metal.
Yeah.
And iron nail is also a metal.
Okay.
Chalk is a non-metal.
Yeah.
And paper is a non-metal.
Okay. Sakshi?
Nail is a metal.
Okay.
Safety pins. Foil
What is it?
is
Safety pin. Is it a metal or non-metal?
it's a metal.
Okay.
Copper wire is metal.
Okay.
And foil is also metal.
All right.
And the wires are non-metal.
Okay. So inside that there's a copper. Copper is metal, but the out plastic is non-metal. Okay.
Yes.
Yeah. And Janvi, what about you?
Foil is a metal.
Yeah.
Nails are not shiny because they were rusted, but they're still a metal. The copper wire is a metal. The paper and the cardboard are non-metals.
Okay. So aluminum foil is metal. Okay. Chalk is non-metal. This is a nail, which is a metal. Safety pin is also a metal. Okay. So we can distinguish looking at them, which are metals and which are non-metals. Now, the metals have a shine. They are shiny. Okay. So what is that property called? It is called lustrous. Metals are lustrous. They have a shine. So they're called lustrous. So metals are lustrous and non-metals are non-lustrous. Okay. We'll move on to the next experiment. Did you all understand this? Okay, we'll move on to the next one. Do you all have a hammer?
Yes, I do.
Yes.
I told you all to bring a stone, a hammer, iron nail, first of all. Okay, so y'all will be performing this. We y'all have to keep this iron nail on top of the stone and hit it with the hammer.
Ma'am, you're frozen.
Now we are checking what are
Yeah, you were frozen
what
and
happened.
your voice was Your voice was breaking. You were frozen.
Okay, am I audible now?
Yes.
Am I audible now?
Yeah.
So what you do is you have to keep a stone. Like, can you show what is the base that you all are using? What like you all are keeping it on a table or something? Is it made up of wood?
Yes, it is.
No.
Okay, Janvi, for you, Sakshi, who said no?
I said no.
Okay, Sakshi, is it made up of wood?
The table, no.
No. Okay. So what we can do in that case is see what y'all will do. Can it be tried now, Swapna ma'am, or should we tell them to try it after
Uh,
class?
what they can do is, they can grab a doormat, okay, and place the stone that you've bought on the doormat, because doormat will act as a cushion, okay, and place the stone on it and place the nail on the stone and then try to hit it with the hammer and observe what happens. Okay, use a doormat, don't break your tiles or the table. No problem, Janvi. You don't have to, the nail is not supposed to be inserted into the stone. You're supposed to hit the
Yeah.
nail anyways. Like, keep the nail flat. Just see the screen, okay, that I'm showing. See, keep the
Yeah.
nail like this and hit it with hammer.
Yeah.
Did you see the screen? Okay, try it out. Come on. And don't be your delicate selves. Use some energy. So touch and feel the nail how it is before you start hitting it. And after, try to make it flat by hitting it. Janvi, this way, so nothing will happen. You're just being too kind with it. Any change in the nail except for temperature? It must have become hot because of friction.
Yes,
Anything
my nails
else?
become flat.
It became flat?
Yes, not that much, but yes, a bit.
Come on, Sakshi, show us your nail.
It's
You've
very
got some
choppy.
superpower.
No, it's very
Is that
choppy.
is that a nail, Sakshi?
Yes.
It is. Okay. So, was it cylindrical and did it become little bit flat when
Yes.
you started hitting it?
Yes.
Okay, good. So you all have to find out, look for the nail that Sakshi has. So bring such thin nails and try to hit it. Yeah. So what are we trying to see here is that metals can be beaten into sheets. Okay. For example, you have iron as a nail. You have the same iron as a piece of sheet, iron sheets. You have iron in the shape of girders which are used for constructing your houses, and the same iron is used in making you know ships, boats. Okay, so metals have this. Was I audible? I was.
Yes, ma'am.
Okay. Yeah, so metals have this property by which they can be beaten into sheet. Now, with like Sakshi could do it, that's very nice, but typically that happens at a very high temperature, and a lot of pressure is to be put to beat any metal into sheet. Yeah, Nicola, ma'am, over to you.
Yeah. So, um, have you observed that the nails have become flattened? Not completely, but yes, a little bit change in the shape of the nail. Okay, from cylindrical to a little bit flat. Okay, so that is called malleability. Okay, the property by which a metal can be beaten into sheets. That's called malleability. So metals are malleable. They can be beaten into sheets. Now, you'll try it with the lead of your pencil. Try hitting the lid of your pencil with the hammer. What happens? Tell us.
Mara broken 2 or 3 hits.
Okay, it broke into pieces. Was it malleable? Could it be? Could it make a sheet?
No.
No. Okay. So we can say that the lead of the pencil is a non-metal. Okay, it's a non-metal. It is made up of graphite. It's made up of graphite. Okay. Janvi, what happened for you?
It crumbled, it broke.
It broke. Okay. Sakshi, did you do it?
Yes, and it broke too.
Okay. So the lead of a pencil is a non-metal. It's made up of graphite, whereas the nail is made up of iron, which is a metal. Okay. So metals have the property of malleability. They can be beaten into sheets, but non-metals are not malleable. Clear? Now we'll move on to the next experiment. Okay. Now for this, you need a battery holder, a bulb holder, wires, and an iron nail or a safety pin. Anything will work.
Ma'am,
Why
So,
don't
yes, Nishaya?
the wires are Will it work?
I couldn't hear you.
Uh,
The bulb?
no, no, Nishriya, this won't work. You need a small LED that we use in the lab.
Yes.
We
Yeah.
need that.
Okay.
Okay, yeah, not all of you must be having the supplies for this activity. So just observe how Nicola ma'am is performing. And later on, you can arrange for your supplies and see if you can do that activity. Okay. And yeah, Janvi, you want to say something?
I have everything except the battery holder.
No problem. So you can directly connect the wires to the battery. Yeah. Try it out. Come on. First, Nicola ma'am will show and then you all can do it. Nicola ma'am, Sriram just joined in.
Okay.
Just Sriram, we are doing physical properties of metals and non-metals today. You can
Okay, ma'am.
and you can keep your video on, and you must not be having the supplies, but just observe, and we'll share the details, and you can carry out the experiments after the class. Okay, Nicola ma'am, you can demonstrate them.
Okay. So, can you all see the setup? This is a battery, okay? And this is an LED bulb, wires connected to the positive and the negative terminal, okay, of the battery. Wires that are connected to the positive as well as the negative terminal, and one end is connected to the LED bulb. The other end is free. Now what we'll do, we'll try to, this is an open end, okay? The negative end of the battery, this is an open end, like we can. Now what we'll do, first of all, these clips are made up of metals, right? Now we'll see what happens. Does the bulb glow? Can you all see?
Yes.
Yes, it's glowing.
Yes.
Okay. Why does the bulb glow? Because this circuit is complete. Okay, there is electricity, the circuit is complete. Okay, but when the circuit is not complete, then the bulb will not glow. Okay, in that case, if you keep an iron nail, let us try it with an iron nail. You put one end, we can clip it on. Okay, does the bulb glow? Because this is a metal, okay, and it conducts electricity. Metals conduct electricity. But if we try it with a piece of chalk, which is a non-metal, let us see what happens. Does the bulb glow? It does not glow, right? Because the chalk is a non-metal. So we come to know that metals are good conductors of electricity. Metals can conduct electricity. We can try it with a safety pin too. This is an open end just for you all to know that metals are good conductors of electricity. Metals conduct electricity, whereas non-metals don't. In the case of a safety pin, now you have put a safety pin and the bulb glows. That means that the safety pin is also conducting electricity, and this is a closed circuit. When you open the circuit, the bulb does not glow. Okay, did you all follow this experiment? How you all have to make it see? You all have to connect one end, like the positive terminal to a wire, okay, the negative terminal to another wire, and that wire can be connected to a bulb. One end of the wire connected to the positive terminal of the battery, and the other end connected to the negative terminal of the bulb. Okay. Then on the other hand, the positive terminal of the bulb is left loose, and the negative terminal of the battery is left loose. Okay. Now this is positive and this is negative, and therefore it's a
So students, are you using a bulb or you all have LEDs?
I have both.
You have both. So try it out with an LED. What about you, Nishraya and Sakshi?
I have a bulb, but I don't know if it's LED or not.
I don't know if I have it.
Okay. See, what you have to do in case if you're using an LED, Janvi, the longer leg of the LED is always connected to the positive terminal. Okay. So what you have to do is connect the positive terminal of the battery to the longer leg of the LED. Okay. Then take another wire, connect it to the shorter leg of LED and leave the other end of that wire loose. Now take the third wire and connect it to the negative terminal of the battery and leave the other end of that wire also loose. Okay. So there are two loose ends, one connected to the shorter leg of LED and one connected to the negative of battery. Now whatever object you want to test, you have to put it in between these two loose ends. Okay. Do you all follow that? Okay. Janvi, can you show us what you're doing?
Yeah, I'm just setting it up. I actually yeah, okay, I just set it up.
Sakshi, can you show us what you're doing?
Um, just a second.
Yeah.
Ma'am, I'm not sure if my bulb is LED or not.
Show, how does it look?
Yeah.
Haha, that won't work.
Okay.
Okay. When we say bulb, henceforth, you have to remember the kind of bulb that we used in the lab for our experiments.
I
Okay.
told my mom that we need that kind of a bulb, but she did not trust me.
All right. Okay. So use an LED, or if you're using a bulb, you have to use the small one which used to be in the torch lights inside the torch. Yeah. Okay, Sriram, did you follow this experiment?
Yes, ma'am.
Did you follow this experiment?
Yes, ma'am.
Okay, do you have the necessary supplies at home?
Not everything.
Okay, all right. What kind of a battery do you have, Janvi? It's a 9-volt battery? Okay.
I think it's out of battery. I'll just check it.
Just check it, yeah.
Yeah. It's out of
Battery is gone.
yeah.
Excellent. Okay, no worries. You all can try this activity. Okay. What about you, Nishraya? Are you doing it?
She doesn't have the bulb, I think. Oh,
I don't have the bulb.
yeah.
Okay. Did you all understand the experiment? We all did closed and open circuit with you all, right, last time? in the last year's classes.
Ma'am,
So
Yes.
basically here, whenever a metal is used in a circuit, it becomes a closed circuit. And when a non-metal is used, although the circuit looks closed, it's complete, but because the non-metal does not conduct electricity, the circuit is not electrically closed, it is open circuit. Okay, so that is this activity. Ma'am, let's move on to the next experiment.
Yeah, I think we are done with this.
We are done with the experiments. Okay,
Yeah.
now let's move on to the explanation.
Yeah.
Is my screen visible to everyone?
Yes.
Okay. So, for example, now we see various things around us. Okay, like a table, a chair, a bottle, a pencil. Now these are all. This is all called matter. Okay. Can you tell me what is matter? How do you define matter? How can you define matter? How can you say that something is matter? It should have two properties. Okay. So matter should have some mass, okay? And it should occupy some space. So if it fulfills these two properties, it can be called matter. For example, we take a bottle. It is having some mass. It's having some mass, okay? And when you place it somewhere, it takes some space. So it is fulfilling these two properties. Therefore, it's called matter. Now, what's a material then? Material is something that makes up the matter. For example, the bottle is made up of plastic. So plastic is a material. Table is made up of wood. So wood is a material. Okay. Your notebook is made up of paper. So it's a material. Paper is a material. Now materials can be classified into two types. That is metals and non-metals. Okay. They can be widely classified into metals and non-metals. Now you can see the pictures. There are a lot of metals that are seen in the pictures. Okay. And what are the properties that you observe when you see them? Can you tell me one property that you see? Yes, Janvi.
they are shiny, lustrous.
Okay. They are lustrous. Whereas the non-metals are not lustrous. They're not shiny. Okay. You can see carbon, sulfur, chlorine, iodine. They don't have a shine. Okay. All right. We'll move on to the next slide. Okay. Now, materials have two kinds of properties, physical properties and the chemical properties. Physical properties are the properties that can be sensed and that can be detected by our sense organs. For example, if we are able to see something, that's a physical property. Okay. If we are able to hear something, then that is a physical property. The sound of something, that is a physical property. Okay. If we are able to touch something and the property of a substance can be known by touching it, then that's a physical property. If it can be detected by any of our sense organs, that is called a physical property. For example, hardness. You can feel whether something is hard or soft. So hardness is a physical property. Okay. You can see whether something is shiny. So luster is a physical property. Okay. Whether it is a solid, liquid, or gas, you can see them. So that's also physical property. Therefore, physical properties are the properties that can be detected by our sense organs. Now, what about chemical properties? They are the properties that we observe these properties only after chemical reaction taking place. When a chemical reaction occurs, after that only these properties are shown. Okay. So these are chemical properties, like how a particular material, how it reacts with something else, how it reacts with oxygen, how it reacts with hydrogen, or how it reacts with acids and bases. So these things will be shown only after chemical reaction took place. Okay, so they are chemical properties. Next slide. Okay. Now we'll move on to the properties of metals. What are the properties of metals? We'll quickly go through this. So metals are solids. Okay. The metals are solids. They are hard. They're very hard. They are lustrous, means they are shiny. Okay. They are sonorous. What is the meaning of sonorous? Means they produce a sound on hitting it. Okay. A different kind of sound. Okay. When you hit a metal, it produces a different kind of sound than when you hit wood. Okay. Wood and metal have different kinds of sounds. So we can say that metals are sonorous. They have a different kind of, we can say, a tingling type of sound. Okay. And metals are malleable. They can be beaten into sheets, which we saw in the experiment, like hitting the iron nail and you made it flat, right, Sakshi? So the iron nail was malleable. So metals are malleable. They can be beaten into sheets. What is ductility? Ductility means they can be drawn into wires. Okay, metals can be converted into very thin wires. So they are ductile. Not all materials can be made into wires. If you hit a piece of chalk, can it become a thin wire? Can it become a thin piece of chalk if you hit a piece of chalk?
No.
No. Okay. What about metals? They are also good conductors of heat and electricity. Okay. Metals are good conductors of heat as well as electricity, and they have a high melting as well as boiling point, and they're very heavy. Okay. They have high density. They're very heavy. So these are some of the properties of metals. We'll discuss one by one. Next slide. Okay. Now, metals are solids. Okay. The metals are solids at room temperature. All the metals are solids at room temperature, except for mercury. Mercury is a metal, but it is not a solid. It is liquid at room temperature. Tell me, what is the application of mercury? Where do we use mercury? Yes, Janvi?
Thermometers.
Okay. So we use mercury in the thermometer. Okay. So mercury is an exception. Now, mercury is a metal, but it is liquid. Therefore, we can use it in the thermometer. And non-metals are found in all the three states. They are found in solids. They are found as solids, liquids, as well as gases. Okay. Solids can be carbon, sulfur. These are examples of solids. Liquids can be iodine. Where do we use iodine? Have you all heard about iodine? Yes, Janvi?
Did you say iodine?
Yes.
I've heard of iodine namak.
Okay, you have heard about iodine namak. Okay, so iodine is also present in the salt. Okay, that's okay. Anything else? Any other iodine have you all heard about?
Is it used for sort of medicine to for wounds?
Yes, it is used as medicine. When you have wounds, you use it as an antiseptic. Okay, before tying a bandage, you put something, you put iodine there. It acts as an antiseptic. Okay, it's used for wounds. And bromine is also liquid, which is a non-metal. Okay. What about gases? There are lots of gases like oxygen, hydrogen, nitrogen. These are all different kinds of non-metals. Whereas metals, you can see in the picture, iron, aluminium, platinum, gold, silver, lead, copper, tin. These are all different kinds of metals. Okay. So metals are all solids except for mercury, which is a liquid, and The non-metals are found in all three states, that is solid, liquids, and gases. Okay, we'll move on to the next slide. Okay, now metals have a shine. Okay, they are lustrous, they have a shine. So metals have a shine, they are lustrous, therefore we use them widely to make jewelry. Jewelry is made with metals. Okay, gold, silver, platinum is used in making jewelry, right? So because they are so shiny, we use them in making jewelry items. And they're also used in making decorative art work. Okay, in the houses, you all must have seen this kind of metal work. Okay, so that is uh, decorative art pieces are also made out of metals. And utensils are made up of metals. We use steel to make utensils. Okay, even copper vessels are used. Copper vessels can be used utensils. Have you seen some vessels that is I mean, do you all use copper vessels at home? Any copper vessel that you all have? No. Have you seen some vessels that are whose base is only copper, with copper? The base
Yes,
is
ma'am.
made up of. Okay. So because they are so lustrous, they find applications in jewelry. They are used as utensils. They are also used in making coins. Okay. So these are different applications of metals because of their luster. Because they're so shiny, they are used in making ornaments and all these things. Okay, next slide. Whereas what about the non-metals? They're not lustrous, they don't have a shine. Okay, they are very dull, they look dull. Now metals are also very hard, therefore we use metals to make in the construction sites. They're used in the construction industry. You can see big buildings are made up of these iron rods. Okay, they are used in making buildings. So iron rods, construction parts, and cutting tools, they are all made up of metals because they are very, very hard. Okay? But there's an exception, not one exception, two exceptions. Sodium and potassium are also metals, but they are very soft. They can be cut with a knife. They're so soft, okay, that they can be cut with a knife. You can see the potassium, it looks like jelly, but it's a metal, okay? Yeah. Sodium and potassium, these are the exceptions for this property. They are not hard, they are very soft. They can be cut with a knife. Okay. And there are, because of the hardness, the automobile parts are also made up of metals. Trucks, aircrafts, these rockets, or their parts are all made up of metals. We cannot say only iron or something. They are made up of stainless steel. And what is stainless steel? It is an alloy. An alloy is a combination of two or more metals. Okay. So stainless steel is made by a combination of iron and chromium. These two metals are mixed together and stainless steel is made, which is very, very hard. Therefore, we use stainless steel in making the automobile parts. Okay, cars, trucks, buses, and all different kinds of automobiles. Even machinery is made out of metals. The agricultural tools that the farmer uses, okay, like the plow, the tractors, the plow, or we can say the sickle, all is made up of metals because they are very, very hard. Clear? Now we'll move on to the next slide. Okay. As we saw that metals are malleable. They can be converted into sheets. They can be beaten to form sheets. You can see the picture there. Okay. Gold is hammered to form a sheet of gold. And you can see how it is malleable. How metal pieces running through those two cylindrical pieces and it becomes flat. Okay, so metals are malleable And gold and silver are the most malleable metals. Therefore, they are used to make the jewelry items. Okay, the jewelry is made up of metals, and therefore, like chains, anklets, and different kinds of things are made up of metals because they are very, very malleable. They can be converted into sheets. Even utensils, you'll see. Utensils are means the metals are converted into sheets, then they are given the shape of the containers. Okay, so they have to be converted into sheets, flat sheets, then only they can form the utensils. So that shows that metals are used, they have wide applications because of all their properties. Okay, you all must have seen silver foil on the sweets. Okay, that is also metal. So they can be converted into very thin sheets and put on top of the sweets. Even the aluminium foil that we just saw. Okay, aluminium foil is converted into such a thin sheet. Aluminium does not look like that, but it is converted into very, very thin sheets. Even we have disposable food packets. See how it is converted into these thin packets, and food, like we can pack food in it. Okay, so it has a wide range of applications because of its malleability also. Next slide. Okay, so metals are also ductile. They can be converted into very thin wires. You all must have seen copper wires. Okay, so how thin they can be converted means when they are stretched, they can form very thin wires. Whereas a non-metal will not act in this way. A non-metal will break. You cannot form thin wires out of non-metals. Okay, metals can be stretched. It can be drawn into thin wires. Therefore, metal cables and jewelry and wires can be made out of metals. Okay, because they have this property of ductility. They can be drawn into sheets. Okay, next slide. They are good conductors of heat. Therefore, they can be used in making utensils. Okay, as I told you that the copper base, copper is a very good conductor of heat also. Okay, so copper bases are preferred, and metals are made up of steel. And how steel is also not a metal, you can say. Steel is an alloy. It is made by combination of iron and carbon together. Okay, that makes steel. And steel is widely used in making utensils and cookware items. Okay, so they are good conductors of heat. Therefore, they are used in making a car. The engines of all the automobiles are made from metals. Okay, the engines, because they can resist the heat, they can conduct the heat. And these generators, heat generators, the iron that we use for clothes, they are all made up of metals so that the heat can be transferred to the cloth for ironing it. Okay, therefore we can say metals are very good conductors of heat. Okay, lead and mercury, they conduct, they are the least conductors of heat. But then why do we use mercury in the thermometers if they are least conductors of heat? Why do we use them in the thermometers if they are the least conductors of heat? Then can anyone tell me? Yes, Janvi.
I don't know the answer. I was just thinking.
Yeah.
Probably know it. I remember knowing it, but I don't remember the answer right now.
Okay. All right. So, anyways, mercury is the least conductor of heat. If it was a very good conductor of heat, what would have happened? The thermometer would have bursted. Okay. If it conducts heat, means it's a very good conductor of heat. But it can conduct heat since it is a metal and it is a liquid. So even if it conducts heat very slowly. Okay, so it is the least conductor of heat, but still it can be used in the thermometer. It does not, the heat, I mean, it is not that much that it can burst the thermometer. Okay, so that kind of heat conduction capacity the mercury has. All right. And non-metals are the opposite of metals. Okay, non-metals are very poor conductors of heat. Next slide. Next slide. Okay, so um, metals have very high melting and boiling point also. Okay, means what is the meaning of melting and boiling point? Who can tell me what is the meaning of melting point and boiling point? Yes, Janvi.
Melting point is when that element or substance melts, and boiling point is the temperature when it boils.
Means melting point is when something converts from a solid into a liquid. Okay, the point at which a solid gets converted into a liquid is called the melting point. And boiling point is when a substance gets converted from the liquid into the gaseous state. So that's the boiling point. So metals are having very high melting and boiling point. Therefore, we use them in the electric bulbs. The filament of the electric bulb is made up of tungsten. Okay, tungsten is the metal which has the highest melting point. That is why when there is it does not melt easily, okay, on being heated up. So therefore tungsten is used in the filaments of the bulb, so it has a very high melting point. And there are many metals that have low melting points also. Non-metals, they have low melting point as well as low boiling point. Okay, so metals are having a high melting as well as boiling point. Next slide. Okay, they are also good conductors of electricity. We saw it in the experiment, right? Metals are good conductors of electricity, so they are used in the electrical appliances like the bulb, fan, fridge, TV, refrigerator. We use it in the electrical appliances because they are very good conductors of electricity. And copper wires, all the wires are made up of copper or they are made up of aluminium. Okay, so they are also good conductors of electricity. That is why we use them in making the wires so that they can conduct electricity easily. Copper is the best conductor of electricity, therefore it is used to make the wires. Okay, all right, next slide. Okay, so metals also produce a different kind of sound. Okay, it is sonorous, the property by which a substance produces a sound. It gives a sound. Okay, a different kind of sound it has. That is that property is called sonority, or we can call it sonorous. Okay, that is why because of this sonorous property, they are used in bells, the school bell or temple bells. They that sound is heard up to a very long distance. Okay, the school bell, the temple bells, it is also used in musical instruments. Metals are also used in the musical instruments because of this property. Next slide. And they are also very heavy. They have a high density. Because they have a high density, we use them in making the counterweights. Counterweights are the weights that is used like in a beam balance. The weights that you use, that is all made up of metals. Okay, the weights that we use, they are the counterweights. They are all made up of metals because they're very heavy. And they also are used in making weapons. They are used in the warfare. Okay, because they are very heavy, and when they are penetrated, they can cause a lot of destruction. So it is used in making weapons and warfare items. Okay, all right, next slide. Okay, any questions?
No. No.
You all have to find out one answer, okay? Write the question. Write down the question. You all have to give the answer in the next class. The question is, how are metals used in the medical industry?
The medical industry.
Okay? Yeah, you all have to
I have
tell
I
us the
have
answer.
one question for them. Now, today we discussed a lot of physical properties of metal like sonority, luster, malleability, ductility. Now, every property doesn't hold true. Like ma'am said, metals are solid, but there's an exception. Am I audible?
Yes.
Yes.
Am I audible now? Yeah. So, like ma'am said, metals are solid, but there is an exception. Mercury is a liquid metal. So, likewise, for every property that we discuss today, there will be exceptions. Okay, exception in like non-metal metals are very strong. That means non-metals are not as hard. So there'll be exceptions. So I want you to go and research about exceptions for every property in metals as well as in non-metals. Okay, like in case of the state, we discussed mercury is the liquid metal and non-metal exists in all the three states. So likewise, find out exceptions in metals and in non-metals for each of the physical property that we discussed today. Okay, and what I want you all to make is, if you're using a full-scape notebook, okay, take 2 pages. Okay, on one page write the title as metals, on the other side write the title as non-metals, and against each, like the first line in metals will be, say for example, malleability. What is the corresponding property of a non-metal, you have to write there, and underneath you have to write the exception. You got it? So two adjacent pages, not back to back, two adjacent pages, so that it is like a tabular format. All right? All of you all got that?
Yes, ma'am.
So the homework for today, the question that Nicola ma'am asked, this activity, and whatever pending activity that you all have from the first class, all of that you'll carry out before the next session. Okay? All right, so next class we'll be studying about the chemical properties of metals. And so it is the same chapter that we are continuing. So we will be putting on the quiz and everything only after we finish the chapter. All right? All right, see you in the next class. Thank you so much. Thank you. Okay, Sriram. Okay, he left. Okay, no problem. I'll call and talk to him. Bye bye.
Bye.